Hello, welcome to watch our video for the group project AutoComplete. Our group members are Zhenyu Gu, Ziye Ling, and Manman Lu. Although it is our first time to work with each other, it is a great experience. So, we start with settling down our goal, that is to create an autocomplete function that search stock tickers or company names in stock market. Let us show you the program first. So we open the file, type in Python autocomplete.py NASDAQ. NASDAQ is a file for our database, which includes all stock tickers and their company corresponding names. We hope the program can be flexible if the user has other data sources. So here we have autocomplete, input, the user interactive window. First, let's try input tickers. The ticker must be all capital letters. For example, I type in A here, it returns all tickers start with capital letter A. The results are listed in lexicographical order. If I type in ME, it returns all stocks whose tickers contain ME. You may select the top, scroll up and down, or to right to see the complete names of all company names. However, if I put in non-capital ticker, like AM, the program does not return matching ticker. We can also search the ticker with non-company names. For example, if I type Google with capital G, it returns its ticker. However, if I type Google without capital G, it returns nothing. The program does the search according to the literal input with the exact match. So if I type bank, it returns company names includes the input word. But if I type in capital B bank, it returns all names with bank listed according to their length. Our program is pretty cool, isn't it? I know you're thrilled to hear what we do in detail. When we try to design the program, we quickly break the problem into two parts. One part is user interactive window. Another part deals with actual processing and sorting. We then break the later part into two smaller problems: class object designs and sorting algorithms. For class object design, we basically use every knowledge we have learned from class. It looks quite simple and clear now, but when we first started, it wasn't that easy to figure out each class and their objects. Eventually, we decided to make three classes, as printed on screen. Their class stock, as the fundamental class for all tickers and company names. Class stock pool, which reads all lines from the data source, split them into individual string, extract needed information, that is ticker and company name, and call the stock class, and then append the result returned from stock. Class autocomplete, on the other hand, takes user input, uses what's being returned from stock pool, call the function of sorting algorithms for tickers or company names, and return the correct result. It also enables the use of keyboard or mouse to select tickers. For sorting algorithms, we choose insertion sort for tickers, merge sort for company names. We use insertion sort for tickers because it works pretty steady for an already well-sorted lists, since the resource we download from NASDAQ database has already been sorted in alphabetic order. However, if the data source is not so well sorted, insertion sort may be too slow to process. We have thought about this problem and kind of struggled on this, which will be told in detail later. Merge sort is an easy pick. It is the most common way for sorting a random list. Other highlights we want to mention is the use of weight of company names. We add this attribute in class stock and set the weight as the length of company names. So when the final sorted result are displayed on interactive window, they are beautifully listed from the shortest to the longest. It is also easier for the user to have a better estimation where they could find the stock. So, as required, we are going to talk about what we have struggled. First thing first, working as an individual for a group project is really challenging, especially in terms of communication. One example is when we had decided for classes, we didn't discuss what attributes should be included as a whole for the entire program. Big mistake. It turned out because each person had different understanding of what each class should do, it became a mess when we tried to combine them together. It took more time to fix them than implement together. So glad that we have learned our lesson and won't experience this again in future. Another problem is choose between binary search and insertion sort. Binary search is definitely quicker to sort than insertion, and that's how we started at first. Nevertheless, it doesn't sort properly. We tried to find out why but failed. Being confused, we switch algorithm to insertion sort. Thank you very much for watching this video. Special thanks to Professor Alvarez and Suzanne for this course.